There's a new problem that has blindsided the fuel industry. You cannot see it, but it will pick your pocket. At this very moment, it's probably attacking your wealth and your assets, and it probably will drive you a little bit crazy. The culprit is something so small that you can't see. But don't be fooled, because what you can't see can definitely hurt you. If you have underground storage tanks and fuel dispensing systems like this, you may have seen this, maybe even something like this. You may have even smelled something like this. The culprit is so small you need a microscope to see it. It stands only 39 ten-thousandths of an inch tall. These tiny microbes are the source of the problem. They consume nutrients from the fuel and generate waste products, including corrosive acids. Left unchecked, these acids will rapidly corrode metals in the fuel system. Preventative action is the only way to avoid needlessly flushing money down the toilet. So how did we get here? What's happened? What is so different about ultra-low sulfur diesel that allows this problem to happen? And the most important question, how do I protect myself and my assets? So what got us here? It was the Clean Air Act, implemented by the EPA in the United States back in 2006. It removed a lot of sulfur from the diesel fuel. Diesel now contains less than 15 parts per million sulfur. The intent of the Clean Air Act was to give us clean air. In general, this is a really good idea. However, as with all good intentions, there are unintended consequences. So are we saying that removing the sulfur is really the problem? The answer is that removing the sulfur has allowed this problem to occur. From our perspective, we've reduced the sulfur from 5,000 parts per million to 15 parts per million since 1993. From the microbes' perspective, a lot of the sulfur compounds we removed could kill microbes or slow their growth. The process that removes sulfur changes other fuel properties. The amount of aromatic hydrocarbons can go down, and paraffinic hydrocarbons can go up. A chemist might talk about a change in BTU value if aromatic hydrocarbons are reduced. Microbes are happy since certain aromatic hydrocarbons can inhibit their growth. The chemist might talk about saturated hydrocarbons and how good they are for cetane number. A microbe again would be happy, as we've served up a better food source compared to aromatics. Ultra-low sulfur diesel seems to bring more water into the system. A microbe sees that as a much larger place for growth. They've moved from a tiny apartment to a sprawling estate. All these changes have come about by the processes used to reduce sulfur to less than 15 parts per million. To summarize the key points, sulfur reduction has reduced the natural immune system or protectants that the fuel once had. It has provided a better food source. The microbes have gone from the lunch truck to a 5-star restaurant. We've given microbes a much larger area to grow in, and the changing environment has allowed new and different species to thrive. A bug's life. But what does happen in a storage tank? We only need a simple formula for problems to occur. A drop of water is adequate, but we usually find more water in the system. Add the right mix of microbes, add some pristine sterile fuel, and, given the right conditions, you get more than you expected. Note the biomass in the middle of the sample. The microbes within this biomass are busy generating waste that will cause operational problems and rapidly corrode equipment. What is the bug circle of life in the fuel system? We've already discussed the simple recipe needed to start things off. Once the 3 ingredients are in the tank, the microbes will start to grow and expand. The speed of expansion depends on the environment. Keep in mind that their 2 adjacent tanks can experience very different growth rates. As with all living organisms, microbes consume nutrients and make waste. In this case, the main concern today is the acid waste products. A scientist might say bugs generate low molecular weight acids. The real world meaning is that the acids will migrate from the water phase through the fuel and up into the vapor space above the fuel. This is why we see corrosion in almost every place in the system. The good news is that you can spend your money and replace equipment. The bad news is that you will go around this cycle until you take the appropriate action. Where would you expect to find problems in the fuel tank? Most people expect problems at the bottom of the tank, where the majority of the water is found, of course. However, we need to keep in mind that a drop of water is the size of an ocean to a microbe. That means we could find a problem here. When you think about it, a microscopic drop of water means we could find the problem here, 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 well, just about anywhere. So how did these microbes get into the system anyway? It could be the truck that delivered the fuel. We often make the mistake of thinking that a clean, dry truck is also sterile. I'm sure that the couplings and hoses are not sterilized prior to every delivery. It only takes a little bit of dust or a drop of water to transfer microbes into the tank. Any access port or even regular tank maintenance can allow microbes to enter into the system. I think this one is self-explanatory. All tanks have vents to breathe. As we pump the fuel volume out, it will be displaced by air. Unless you have a sub-micron filter, you can bring microbes in with the air as the fuel is dispensed. So what is the cost of having microbes in the system? One example that we're aware of is a tank cleaning and replacement of a significant number of parts we've listed here. So what is the real cost for this one tank? The expense seems quite high when you consider that it's all avoidable. So how do we solve the problem? The first point is nothing new. It's housekeeping. Year-round housekeeping can reduce a lot of these problems. Check for water frequently. Remove the water bottoms and physically remove any biomass or sediment. The second part is knowing what's taking place in your tank. Is there adequate routine monitoring and testing to understand what is happening inside the tank? Manually checking for water levels to back up electronic systems. Laboratory tests to culture for microbes or looking for the presence of ATP, adenosine triphosphate, the stuff of life. And if there's ATP, there must be something biological in the tank. Check water bottoms to see if they are getting acidic or maybe basic. This type of information is what you really need to properly protect and maintain your assets. The last piece of the puzzle is understanding that the proper biocide application is important. Are you using the correct biocide for the situation? Should you use a fuel phase biocide or a water phase biocide? Does the biocide kill bacteria and fungus, or one or the other? Is the biocide sulfur compliant with the EPA regulations? The correct treat rate is very important. Too often people use the lowest treat rate, which is likely the maintenance dose. The low dose might slow down growth and kill some of the weaker species, but the stronger dominant species come back with a vengeance, causing greater damage. It's important to realize that a significant microbial problem would require the lethal or shock dose and possibly a follow-up dose. The third critical item is contact time. Different biocides require different time periods in order to achieve full lethality. It is important to work with a company that can give the correct guidance, which will in turn maximize the effect of the program. The key point is that the wrong biocide and or inadequate contact time and or the wrong treat rate will probably lead to failure and disappointing results. In summary, the best way to control the problem is to be proactive. We cannot stress enough that housekeeping is the first line of defense. The second key point is knowing what's going on in your tank. Frequent checks for water, appropriate laboratory analysis, and data interpretation give you the information you need to make the appropriate choices. Knowledge of the tank conditions and knowledge of different biocides and how they function is the third key critical point in the equation. Improper application of biocide often leads to greater expense and frustration. Proper application leads to success.